welcome everybody. Today we have Justin Denton with us talking about how to buy a 3D printer, a subject that I think with it getting harder to get out to maker spaces is probably near and dear to a lot of folks' hearts. Um, we don't have mics or screens turned on for our audience, so if you have a question, go ahead and put it in chat or use the Q&A feature. Justin, is there particular times that you want to take questions, or do you want to take them as they come?
You can, if you have questions, go ahead and toss them up there as we go. I can, if I've got a minute, I'll stop and we'll answer them as we're on the slides. Otherwise, there's some little areas where I'll make pauses and we'll go back and review the QAs.
All right. So if you're ready to go, Justin, go for it.
Sounds good. Hi, everybody. This is Justin Denton. We're going to be talking about buying a 3D printer. As you can see on the picture, 3D printers are a huge opportunity and a lot of fun for everybody. And even if you don't have a 3D printer and you have access to a 3D printer and you want to just tinker from scratch, there's even models out there where you can just print your own 3D printer. So it's really cool to be able to do a lot of this stuff. A little bit about myself. My background is in technology and developing new technologies. I developed a bunch of new technologies while I was at IBM, which are still being used today. A lot of them were deployed to IBM machines from 2002 to 2011. But the products that I developed back in the day, which were in the late 90s, early 2000s, are still being used today at IBM. They've been built out into their own standalone corporate product. Prior to that, prior to my current career, I was the program chair and acting dean for the School of Technology at Rasmussen College. Always drove technology efficiencies in the workplace, as well as just life in general. My wife probably gets annoyed a little bit. I'm so techie all the time. As I sit in my office, I have like 4 computers, 3 tablets, a couple phones, all sitting around me, and that's just at my desk, and that doesn't even encompass the rest of the house that I've got stuff drug all over. So love tech, and I love to be able to talk about it. Right now, I'm currently the Director of Support Services for Collegiate Education. I currently manage 40 to, actually it's more than 40 now, but over 40 colleges and universities online classroom environments, from the technology aspects to providing student support. I also, at the same time, own and operate a 3D design firm called 3 Denton Auto by US Vet Designs. We specialize in automotive product production, focused on designing, building, and using FDM production methods to build out our products that we use. So as you can see, I work nonstop. So hopefully you'll notice how much in depth we can get into the 3D printer side. So I will hop over to the next slide and really kind of talk about what the topic is today. So today's topic, we're just really going to focus in on what 3D printers are, what can I do with them, what kind of features that I would need to look out for, and really which ones I should buy. Hopefully the goal is to leave you knowing which printer you want to purchase and moving forward with that purchase at the end of this discussion today. The agenda on the docket for today is we're going to talk about what it's like to own a 3D printer. Hopefully some of you have been able to play around with the 3D printers or have went to the maker spaces, or maybe you already have one yourself and you just want to get another perspective. We're going to also talk about what brands are the best, which ones will get the job done. Obviously, you don't have to go out and buy the most expensive 3D printer in the world to get some basic jobs done. We'll also talk about how much effort you're going to have to put forth. I'd love to say that you could unbox a 3D printer and hit print and it would work. Some options, they're a little bit more costly, have that ability, but some 3D printers you'll need to tinker with just a little bit before you can start printing from them. So we'll talk about that, and that's another factor that you want to weigh in when you're making your purchase. Obviously, 3D printers can cost well over $10,000, but you can also pick some up for around $100, and we'll discuss what those will do, and do they do the same thing, and or is there one better than the other? We'll talk through the features of the various 3D printers. Printers, as you can dive in, aren't just there to print. There are a lot of additional options that are available for a printer to make your life easier in some instances. Some instances it can be a little more painful because it's just another item that could potentially break. So we'll talk through those and really figure out what are the best features that'll fit your lifestyle. And then lastly, the end goal is to give you a couple recommendations on printers that hopefully will fit your needs. So if you want to post in the QA or in the chat, who already has a 3D printer right now? Let me bring up my chat forum too. Got a few windows up here. As we go, if you want to take a moment, you can go up to the Zoom control panel and either click on QA and toss a question in QA, or click on more, hopefully on your side as well, and be able to click chat. You may already have a chat button available. I see Al does not have a 3D printer. Hopefully, Al, you are looking to get into one. Obviously, you're here with us, so you're in the right spot. Obviously, see with this picture on the main screen here, printers can be very, very basic in terms of you have to build them. Obviously, there's some really basic threaded rods, some nuts and bolts, and this is one of the more earlier model 3D printers where it wasn't a pre-made kit. You had to tinker with everything to get a printer going. So feel free, throw some stuff in chat as we go through. But, you know, see Jessica has, they don't own one yet, but we'll definitely take care of that for you. Hopefully we can help you make that decision. A lot of the pictures that you'll see through the presentation are of my own 3D printer farm. I have roughly 25 3D printers. I just got in 3 Prusa Minis actually this past weekend. So they will, or actually 4, sorry. So I'll talk through about a lot of those too. I've got a lot of experience, good and bad, with 3D printers. So what's a 3D printer? Really, the basic rudimentary way about this is it's a mechanical device that works very similar in terms, or in a basic standard, works very similar to regular standard printer. You basically load up what you want to print. Obviously, you're not printing a Word document, but you load up a model, something that you made through a CAD program or you've downloaded online, and as long as you have that printer connected to your computer, you press print, and the printer does the rest. If you don't have it connected to your computer, a lot of the printers either have Wi-Fi connectivity or will read an SD card. You save it over to an SD card, you go over to the printer and you hit print as well. You wait a few minutes. Actually, I don't know if anybody's, hopefully people have already tinkered or seen how long or lack of time that it takes for something to print. But if it's a really small model, you may get it printed out in a matter of minutes, usually 10 to 20 minutes for something very, very small. We're probably talking something a little bit bigger than the size of a button. If it's a larger model, it's not uncommon, based on what resolution you use, to take upwards to over 24 hours to print something. So you definitely have to have a lot of patience with printing, but it's definitely fun. You get used to it. When I first started doing this, I was very impatient. I guess I have that type A personality, go, go, go. And, you know, I couldn't imagine how long it took me to print my first model. And I say I waited for like 4 hours and I printed something the size of a action figure. And I kept thinking, man, that took way too long. Either way, along with this, the 3D printers typically consist of some sort of frame. They're usually made of varying materials. A lot of times you see them in metal lately. Some of the older models were made in plastic and wood. And then even today, there's usually a mix of at least metal and plastic when a 3D printer, when you receive a 3D printer. The reason for those plastic parts is many 3D printer manufacturers like to make their devices where you can repair those pieces yourself. So they'll have models available so you can reprint out parts. Like this picture over on the right side of your screen, the green parts, the yellow parts, even some of the black pieces that hold connecting rods. The company, which is Lulzbot, has models that you can print out, replace those parts, because over time those parts tend to crack, but they want to have some level of flexibility into those parts. So metal wouldn't really do the job because it would be too rigid in certain areas, whereas they can use plastic. It'll flex just a little bit because you want to have your printer to have just a very tiny bit of give. That helps from gears from binding up, and that we'll talk more about all the mechanical and technical pieces in a later webinar that I'm hosting in the next couple months. Click the slide too quickly. Also, you've got your motors and belts. You can see those on the that hold the drive accesses up. The print head, it gets extremely hot. I've burnt myself many times. It's not fun when you first do it, but then all of a sudden you become impervious to pain after you do it enough times that just know that print head gets sometimes up to 240, 270 degrees Celsius, which is about 400 degrees Fahrenheit. So it can be very warm, and it can melt skin quite quickly. I have experienced that. Usually your fingers, because you're trying to clean your nozzle when you're doing that. Some sort of controller board, I like to call that my motherboard, just like a computer. And then you'll need to have some software to use to create, render, and really print objects. So laying down the groundwork, there's definitely a lot more we could discuss. We probably could have a whole webinar just discussing all the individual pieces on an actual printer. But let's talk through what it's like to own one. As owning one, it can be great, it can be painful. You'll have a love-hate relationship with your 3D printer, because if you don't have a service center, like where I'm at, I'm probably the only person other than my schools that know how to manage 3D printers and build them and repair them. You'll find yourself learning how to do that. When I bought my first 3D printer, I had no clue what I was doing. I just knew I was going to do it. And I wanted to create cool things. These are some pictures of some of the stuff that I've created over the years, and they're really cool when you're printing them out. For some reason, I got interested in printing out the Lulzbot Rocktopus a couple times. Everybody prints a Benchy, which is the big boat, and then the other one is a little light bulb holder for a Amazon Echo Dot. So you can definitely print a lot of cool things. You'll find that you print a lot of excess stuff that you really never knew you didn't need, and you probably don't really need it, but it's really cool just to print it out and see how well your printer's working. Looking at the finishes on them, as you can see with the boat, the finish is really nice. The finish on the yellow octopus, the reason why it has a very poor finish is there's a different print heads that you can use with your printers, another accessory or option, depending on what printer you have. It prints out at a higher resolution rate. So normally if I would have printed that octopus with a normal base model print head, it would have taken me a good probably 20 hours to print. I used a Lulzbot Moorstruder, which has a significantly larger nozzle on the print head, and that same octopus prints out in about 2 hours. But obviously quality suffers when you're doing something like that. But besides all the cool things, there's also the not so cool things, the things that you wake up to and you walk in the morning, go back down and check your printer. You find out that your print job has either detached from the print bed and fell over and you have a big mess of spaghetti. You started printing perfectly fine, and the material you were using globs up a bit and causes your printer to deform towards the top. Obviously, the top left picture is that. You can also run into various printer errors that causes layers to shift, which is called layer shifting. So very, very simple terminology. But the top right, that was what a case of layer shifting looks like. And then on the bottom, if you've got a belt that's slipping or an actual hardware error, this model is supposed to stand straight up. It starts tilting to the back of the printer. So little things that you have to learn how to diagnose along the way. For me, my first was a XYZ DaVinci 1.0. I had no clue about printers. One of my friends talked about them. He works in libraries, and he said they were the greatest thing in the world. They were still a little pricey around then, but I happened to go to a local pawn shop and saw they had a 3D printer there. And I thought, all right, well, let me negotiate. I got them down to $200 for the printer, and I took it home. Let alone, I tried to do a print. It wasn't that easy. It wouldn't print right when I first grabbed it. Because it was sitting in the pawn shop for over a year, because normally people don't go to the pawn shop to find a 3D printer. It was just by accident. I had to play around a lot with this printer. Probably wasn't the most ideal situation, because I basically bought somebody's secondhand printer that they wanted to get rid of. There was errors with it. I had to troubleshoot a lot of it, and I did a lot of learning. At the same time, it was probably the best $200 I spent, because it made me and forced me to learn how to fix and repair printers. I learned a lot about the XYZ printers while on the way, and I bought 3 more after that, because I felt very confident about being able to tear this machine down and put it back together in just a matter of a few minutes to an hour. It was the perfect tool for learning, but probably didn't give me the best experience right out the bat. So taking a negative and turning into a positive on this one. It was a lot of trial and error. I did get it up and running. Print quality was never the greatest on this printer, so I ended up getting rid of it after about 6 months, and then buying a new printer after that. As you can see, as soon as I powered this printer up, I got that error. Error 0031, which is a random error to me, because this is the first time I've dealt with 3D printers. And I had to go in and fix some errors with it. The print head was jammed with filament, which is a very common issue. And, spent a lot of time trying to figure the whole thing out. I believe it's on December 28th. I have another webinar for how to maintain your 3D printer. So I'll cover all the tips and tricks I've learned. I've tore down so many 3D printers. I actually would wish I could forget about some of them, but we'll talk through all my trials and errors. So at least I prepare you. I can't say that inevitably you won't have those same issues, but hopefully after that session, you'll feel confident about being able to rip something apart and fix it. So as you can see, I've showed you a few different printers where of my own, where I've taken pictures over the years, and little issues. This one was the same issue as the picture ahead. The filament got jammed in there. The temperature didn't hold, or it was poor filament and caused my printer to jam. But like I said, I got my first printer working, and I ended up buying a different one, because I figured this pawn shop printer was probably not the best experience, so I bought an out-of-the-box printer. On the right, the first print was amazing. It did a great job. And actually, subsequent prints were really well. But then I realized that was the big aha moment, that even if I bought a brand new printer out of the box, it will print fairly well, because this Monoprice Ultimate out of the box prints beautifully. But inevitably, you will still have an error. This is when I personally learned that 3D printers are going to require a little bit of a break fix along the way. Again, don't get discouraged. It's not really hard. All the parts are very inexpensive. So if you happen to break something, you're only talking like a couple bucks to fix a mistake. It's not like you have to rebuy the entire printer. You just have to fix a little wire or a fan or something like that most of the time. But like I said, I ended up printing tons of stuff, and you know, the addiction expanded and turned into the 25 plus printers I have right now. So the picture on the right is where I started to expand my collection. As you can see on the bottom, there's two XYE DaVinci Pros, which is a little bit better model, two Monoprice Ultimates, and then I got these two Power Spec printers as well. I bought those off eBay. They were fixer-uppers. At that point, I felt confident that I could tear a printer apart and I could fix it. So to save a few bucks, I went on eBay and bought a couple broken printers and fixed them myself, knowing that sometimes they require no money spent to fix, and sometimes, you know, it's minimal, 10, 20 bucks to repair one. What I personally say are the best printers is I really love Prusa and I really love Lulzbot. I say Sendever as well. Sendever is a new brand that Lulzbot sold out to a company in Fargo, North Dakota. Sendever is a company that rebuilt out back in Colorado and hired on some of the former Lulzbot employees and designed their completely new printer that's very similar to the design of a Lulzbot, but improved some of the features that, if you're a Lulzbot user, or tend to be a little annoying features that you have to live with, Sendever fixed those annoying problems. Either way, as annoying as those problems are with Lulzbot, they're very reliable. I have a Lulzbot printer that I've been running for the last year and a half, 2 years straight. The only problem I've had is the nozzle gets a little filament jammed in occasionally. That's more than likely my fault. I probably had some bad filament or something of that nature. They're a little bit more pricey, so you get what you pay for in those regards. Less maintenance and more reliability. Which ones are the most affordable? There's Creality and their Ender product, and Monoprice ones are very affordable. They're usually at a couple $100 range, and a lot of those more affordable printers are usually $100, $200, and they require you to assemble some stuff, so you'll have to take your time on putting them together, but you'll learn a lot of skills while you do it. The best bang for the buck, Ender 3, obviously, hands down. I haven't purchased one myself, but I know I have a couple friends that they just swear by Ender 3s. I haven't purchased them because I don't really have a lot of time on my hands to sit down and build a printer from scratch, and that's what you have to do with an Ender. It takes a good 12, can take up to 10, 12 hours if you've never done it before to put your printer together and test it and get it all tuned and ready to go. And as much as I'd love to be able to do that, I don't, my life doesn't permit a pause of like 10 to 12 hours to put a printer together, but it's definitely something worthwhile. Otherwise, if you want something that's just no assembly required, it's very inexpensive. I swear by the Monoprice Mini. It's a quick printer to toss in the room and just start printing. So what do I use them for? The picture in the top right is my room. I just finished up just a few weeks ago, actually, where you'll have I have a bunch of Lulzbot printers. I still have those old XYZ DaVincis and the old Power Specs, and some Prusas in there. And my stack of 4 Prusas that I just got in the mail. But I use some expensive ones. My expensive ones are really my ones that are more reliable, that I can say, hey, I don't have to mess with these. They'll just print no matter what. And those are my Lulzbot Taz 5, Taz 6, Taz 4, and my Prusa MK3S. I have 2 of those. My mid-range printers are my Lulzbot Taz Minis. I have 5 of those. There's only 2 in the picture because I've had three, I bought all my Lawsbot TAS minis used, which again, if we go back to the beginning of this, if you buy a used 3D printer, you may end up inheriting someone else's problems, which I did on a few of them. It was a really good deal. I paid a couple $100 for some Lawsbot TAS minis, which are normally $1,000 or more, and inherited some problems. So a few of them are in my fixer-upper mode. Just got my Prusa minis, and I love my power specs. All they are is a rebranded FlashForge Creator. A FlashForge Creator, they just work. They have a nozzle jam issue where occasionally filament will get jammed in the nozzle. You tear that apart a couple times, you get very, very quick about being able to tear the nozzle apart, fix it, put it back together. You can do it in about 15, 20 minutes and have the printer back up and running. With that, that's the only problem I've ever had with mine. So I feel very confident with being able to tear those down, put them back together. So I just keep them. The print quality is amazing still on them. And those are a couple of my, after I bought those ones and I got into fixer-upper mode, I've bought these, and these printers I've had for about 2.5 years now, and they just run. So I would say if you can find those, you can definitely have a pretty solid machine. So hopefully everybody's up for the challenge. I know there's some fun aspects, and there's some that can cause you to pull your hair out with 3D printing. Waking up to a print job that has failed, very similar to this one. I woke up in the morning and I saw my glass build plate knocked off onto the bottom. I have no clue how it actually landed directly on the bottom of the base of the printer, and then just a mess of filament everywhere. But that was my challenge. You figure out that you've got to do some things to fix that, and you go ahead and move forward with it. How much effort do you have to put forth? Obviously, there's some effort we've talked about, and it's fun along the way. You can see where spend time rewarding yourself by doing little tinkering projects. I wanted to be able to get my 3D filament up off of a stack off the floor, so you can 3D print shelf brackets, buy some 1-bys, very common template that's available on the internet. Print them out, put them up. Helps me reward myself a little bit when you're doing all those trial and errors. So I guess really the difficulty really falls around, do you want to buy a kit or do you want to buy one that's pre-built? A lot of the ones that are pre-built are also pre-tuned. And when I say pre-tuned, you can just unbox it and hit print and you're good. Prusas come both ways. You can get them as a kit and you have to do all the legwork on them, or you can get them as they do all the pre-building, tuning, everything. And when you unbox them, they print amazing quality. The little pig in the bottom right of the screen is off a Prusa that was brand new out of the box. And the print quality is very, very, very good for something straight out of the box without even having to do anything. But either way, I always recommend that you want to watch the videos, you want to read blog articles and dig up a lot of the different types of things that you can do, the materials that you can use. I see Mike Olmsted says he currently has a Wanhao D6, which is the same thing as a Monoprice Ultimate, although Wanhao does have some better parts than the Monoprice. They definitely had some a little bit cheaper parts in the Monoprice version. But it's a great way to do, like you said, upgrade, do a lot of prototyping. There's some great filaments out there, nylon, carbon fiber, and we'll talk about which ones will get the job done for under 4K, definitely. So obviously under 4K is definitely not a 10,000 plus printer, but you can definitely get some that you can do the job for $100. The $100 ones are going to be more of a kit type printer. There are some inexpensive, smaller form factor that are around $100, especially on Black Friday deals. So we'll see a lot of those coming up now, where you'll be able to get a one that you would only have to put in like 4 or 5 screws and have it built out, and it would only cost you maybe 100, 125, hopefully on some sales next month. Just know that the $100 printers usually require a lot of extra tinkering, and you'll build a lot of skills, but they won't be always ready right out of the box. So I have $100. There's a ton of different printers and makes and models out there. If I personally use various makes and models out there, I mean, I don't always say brand is everything, but depending on what you want to do, like Mike has asked, it can be, especially if you have a more of an engineering requirement, wanting to use nylon or carbon fiber. You have to look for special features on those printers to be able to accomplish those type of, they call them exotic materials. There's some additional materials that you can use that have steel and other metals ground up into the filament that'll fuse those together. The maker, it's, I can't remember off the top of my head. There's one manufacturer that makes a great model that can print all the engineering materials, but again, it's one of those $10,000 plus printers. And what to do with the expensive ones? Like Mike has alluded to, you've got your engineering applications. You either want to build a large model. The bigger the print surface, typically the cost goes up. And there are even more fancy 3D printers where they're using concrete and other types of material. If you look online, occasionally a sale goes on where they have a 3D printer that prints pancakes to a hot plate, and you can print your own pancakes. There's a lot of special materials like carbon fiber, nylon, reinforced with steel and other types of, or even ceramic type materials that help produce a very, very strong product. And essentially, some of these products can be substituted for a metal product and have the same level of reliability after running them on a 3D printer. And obviously, the more expensive ones can be more reliable, but at the same time, the same things can break. You may have a nozzle that's jammed up with filament. You may have a motor that went bad, or a bearing that went bad, and you'll have to swap all that out. It can happen on the expensive ones, or it can happen on the cheap ones. So just mean time to failure is typically longer on a little bit higher priced machine. Even on this one, this is my my Lulzbot Taz printer. On the top, you can have very simple things like the PEI sheet, which a PEI sheet is the sheet of adhesive that's stuck to a piece of glass. And that adhesive, when it gets warm, gets a little sticky, and the print adheres to the piece of plastic, or the plastic sheet. When it cools down, it starts to release, and then it'll typically pop the print loose, depending on what material you use. But a potential issue when you buy a Lulzbot printer, which cost me somewhere around $2,000 at the time, $2,500, is that sheet can delaminate from the glass that you were using on. This is actually a fairly new build plate, and it was, in this instance, was a manufacturer's defect. But knowing that ahead of time, that's a possibility, then you have to work out with the manufacturer if they'll cover it under warranty. For this time, I happen to have the problem around when Lulzbot was transitioning ownership, so I could not get this one support or applied under manufacturer warranty. So I had to just repair it myself. On the right, this is a Lulzbot Aerostruder. which is a very, very nice print head for the Lulzbot printer. But again, common, or not a common problem, but I had a problem with mine jamming up, and I tore it apart, found out that this was an earlier printer that I had, and a piece of filament got stuck behind and was causing some issues. So I had to tear the actual print head apart, clean it up, put it back together. Life was good. I spent no money doing the job, just got good at taking some bolts and screws apart to actually tear it apart and just reassemble it the same way. I've never had to do this again. It was just a one-time thing. I've used this printer for a year straight now, and about 6 months in, I had to do this. It was just probably a end user error on my part, but otherwise, it worked really well. So we've talked about a bunch of at least hopefully setting some expectations on what type of issues that can arise, setting expectations on what type of printer that you may or may not want to utilize. Should I build it myself? Should I get one that's pre-built? But then there's also the different features that we should be looking at. There's a lot of different features. Is it a genuine E3D hot end? It's a very, very popular hot end manufacturer. The nozzles they print are quite premium. You can get a lot better print quality if you have a genuine E3D. A lot of manufacturers use aftermarket or generic E3D models, or there are some other manufacturers like Ender or Creality that have their own nozzle that is fairly good. But if you're going for a premium materials and having really good print quality, sometimes it's best to get a better print head. Along with this, a micro Swiss hot end is key. There's two different types of constructions of a hot end on the inside. So like on the Wanhao D6 or on the Monoprice Ultimate, that initially is not a micro Swiss hot end. It has what's called a PTFE tube, which is essentially like a plastic tube on steroids. It has a lot higher heat resistance, and that's inserted into the inside of the hot end on that 3D printer. The hot end is obviously that on the top right, that hot nozzle that gets 240 degrees. In that threaded area above, that is where that plastic tube would sit. If you have a micro Swiss upgrade, and you can upgrade a Wanhao, or you can upgrade various printers, even if you don't have that, you can upgrade the hot end to have a micro Swiss hot end, which is an all metal hot end with no plastic insert in the center. Sounds a little scary because that metal on the bottom gets 240 degrees. Obviously that heat can radiate up the threaded part. The plastic is to insulate that so your filament doesn't melt before it actually gets to the end of the nozzle. When you get an all metal one, there's like an air gap in the center of it, in the edges of it. So there's two pieces of metal with a little bit of an air gap between the two. That keeps and helps ensure that heat isn't resonating all the way through that metal end, and allows you to push filament through. The net result is a micro Swiss hot end allows you to achieve 300+ degrees Celsius, which then allows you to do nylon, carbon fiber, and so forth. It also, you want to couple that with the actual micro Swiss nozzle, which is either a stainless steel nozzle or a ruby nozzle on the end. So if you look at that hot end where it's touching the orange octopus, that's brass right up above that. You would swap that out for a harder metal, like I said, stainless steel, a ruby nozzle. There's some other hardened materials that you can get. They're usually a very, very cheap upgrade If you buy them off of AliExpress, you can get that upgrade for just a couple bucks. You swap that on, and then you've upgraded your existing printer to print things like nylon, carbon fiber, and so forth. When you print those, you usually have to print those materials at either a higher temperature, or you need to have more rigid printing material available. Nylon has to be a higher temperature. Carbon fiber, you need to make sure that you are using hardened material such as stainless steel, etc., because carbon fiber can over time act like sandpaper when it's going through a printer and wear out the nozzle and wear out other printing components. But once you do those upgrades, you can upgrade almost any printer to be able to do some of those higher end materials. Another one is having either BL Touch or a Pinda auto probe, which is will give you auto leveling on your printer. One of the common practices when you have a printer is you're going to have to level the bed. Everybody, it's like 3D printer 101. If you don't have a level bed on your printer, then it will, print job will fail. Some of the print jobs that I have shown earlier where they fell off the printer was because I didn't have my bed perfectly level. You want to get a printer that either has an auto level probe, because that'll take the work out of it, or get a printer that has some sort of semi-automated bed leveling. You can get like some of the ones we've already discussed have both of those, or either or you can go with a very basic printer that doesn't have any options for auto leveling, and you would just need to go through a process to manually level yourself. We'll talk through that in the maintenance section, our maintenance webinar. But in those regards, you would need to start the print and use some paper, and there's little turn knobs on the edges of the print bed, and get it leveled where it's the print nozzle is only the thickness of a paper between the print nozzle and the bed itself. I personally like direct drive extruders. The direct drive extruder is is a lot better with pushing filament through the printer than having what's called a Bowden extruder. So depending on when you look at various printers, the filament will go directly into the print head, or the filament will go through a tube that's pushing filament through the print head. A couple different options there. Personal preference, I like the direct drive because with direct drive you can use flexible filament, but there are now printers that allow you to do it with the other model too. Printers have a lot of different firmware options. Marlin firmware is quite popular, and it's an open source model firmware. So out of the box, it works beautifully. If you want to customize it and you get really into doing 3D printers and you want to write your own code, you obviously can. They actively keep it updated. And if your manufacturer that you select is actively participating in those updates, then they'll keep it updated as well. There are some other manufacturers that use various versions of the Marlin firmware where they've customized it to their own printer hardware. And there's alternatives as well. But this is one of the more standard firmwares to utilize. Some of the custom ones, if you choose one of those that's not Marlin firmware, you're up to the manufacturer sometimes for them to update it, which means you may not get an update anytime soon. Like XYZ DaVinci, they create their own firmware. The downfall is it's not as flexible as some of the other printers out there. The print quality can be just as good. Just if you wanted to set up something like an application called Octoprint to manage your printer remotely, it doesn't work with an XYZ printer. At least the old ones. I think the new ones, that's no longer the case. We'll run through the rest. I can talk all day about various options, but removable PEI build plate. We talked about what PEI is that sticky sheet. They make those that are removable now. So having that is an amazing option, because if you start having that printer problem like I did on the one, I can just remove the whole plate, replace it for just a few bucks, and keep on printing. There's Bondtech extruders. having a rigid frame. If your frame just wobbles all over the place, that means when it's printing, it's going to wobble all over the place, and your print quality is going to be quite poor. Having Octoprint compatibility, which allows you to remotely manage your printer and print from it. Color touch screens, having a larger print volume, having the ability to print multiple colors, either by one single extruder, having multiple colors going into it, or having multiple extruders, which an extruder is going to be that whole assembly where the hot end and everything else is, all the fans and everything else. Having self-calibration, auto nozzle cleaning, and then we talked about automatic bed leveling. Some of these are niceties that you get with a like a Walls-Bot or a Prusa. The Prusa will auto level but doesn't do any auto nozzle cleaning. The Walls-Bot will also clean your nozzle as well, which comes in handy. So I don't have to really do much. It self-maintains itself. I guess, which printer is right for me in this regard. If you're looking for the cheap DIY kit and you just want to build a printer on a budget, take your time. You have nothing but time to spare. You want to get used to how to put the printer together, and by putting your printer together from scratch, it's a great way to really get an idea of how all the parts work, and also how to give you basically printer repair 101 skills while you're putting it together. It's a great option to go with an Ender 3. After you're done building it, the print quality is quite good for a printer that can run typically about 160 to 240. There's a little bit higher ones, but this one can give you some nice print quality, teach you some great skills, and not really hit your wallet too hard. Can you print exotic materials and stuff? You can't out of the box, but like I said earlier, you can upgrade those parts to be able to print additional materials. You'll want to go through, when you're building a kit, you typically have to go through the building and tuning experience where you're printing out filament, making sure your print quality is good, checking your settings, adjusting and tweaking settings until you get it perfectly right. There's a lot of blog articles and YouTube videos available for an Ender printer, so it makes it very easy to be confident about taking on this challenge and really putting together a great printer. And the thing is that normally when you buy an inexpensive printer, the part quality of what they give you to build the printer isn't the greatest. One cool thing about the Creality Ender 3 is the print quality on this printer and the reliability of the parts is quite good. I have a friend of mine that has, I want to say 10 of these, and very rarely does he have any issues with them. I see Jessica says they've looked in the Creality Ender line. There are indeed a few variations. They just came out with the Ender V2. The differences, I would say on the V2, there's some nice differences. On the V2, I believe it's got a color touch screen. I want to say they put auto bed leveling on it, whereas the cheaper model doesn't have those features. I guess the net result is, if you foresee yourself really getting into 3D printing, it's probably worth buying the version 2, because over time you're going to want to put those upgrades on, and you're going to end up buying those pieces anyhow. So I always say that now. If you would have asked me 2 years ago, I would have said, go for the Ender 3, the Pro version. It's less expensive, it gets the job done. But after having some printers, I went with the cheap ones, knowing that I wanted the Prusa first, but I didn't want to spend the money for the Prusa, because a Prusa is typically around $1,000. So I went with the one that was like a couple $100 that I got from the pawn shop, and I bought a couple others that were relatively cheap as well. But I ended up still wanting the Prusa, because the Prusa had a bunch of quality upgrades to it already that I didn't want to do, or didn't want to. I tried applying. I spent some money on some of the ones I already had and could never get them to be as good. So I ended up just biting the bullet and going with the one I wanted in the first place. So if the price is still within your budget to go with the V2, I would say the upgrades are worth it. If it's not in your budget, then no worries. Go with the Ender 3 Pro and really just get used to that. And then over time, you can spend the extra 10, 20 bucks here to upgrade the pieces that you'd like to upgrade. So you've got the cheap and out of box experience. I always recommend the Monoprice Mini. It is a small machine. It looks very basic when you see it. The cool features are it has an E3D hot end on it, which means the print quality is quite good for a printer that you can commonly get between $99 to $200. Most of the time it hovers around the $99 to $120 range. The $200 end, there's a Monoprice Mini Pro, which the cheap model works just as good. It's very basic. It's one of those printers that you pull out of the box and you're ready to print. It may require a little bit of auto leveling, but it has its own auto leveling sequence. Almost all the 3D printers I've gotten that were Monoprice Minis out of the box printed, I didn't have to do any tweaks to them, and the print quality was quite good. There are a couple known issues because it's an inexpensive printer. This one does have a couple of those known inexpensive printer issues. You may be printing on it for a couple months, depending on how heavy a printing you're doing, and find out that you need to, upgrade or fix a wire or re-level the bed or something like that. But on mine, even on my Mini, very rarely does that happen. I think that happened once for me where I had a heater bed wire break on it. But it's very basic wiring, so you just have to find out where the break is and splice in a new wire. It's very well documented because there's a great aftermarket support for the Mini. And it takes up like no space at all. It's about the size of your kitchen blender. So it's a very small printer. That means it also prints very small models. I think the build size is like 5-inch cube or maybe 6-inch, but somewhere right around that. So you don't get a huge print volume, but it's a good thing to start with if you just want to try printing and see if this is really what's for you. You don't want to undertake the challenge of building your own printer, but you just want something that you can toss together and start printing immediately outside the box, and this will get the job done. I can't even say I've ever had a nozzle jam on mine. I think that might be because it has the E3D hot end. The E3D hot end is very good at regulating the temperature and keeping a constant temperature, but I could have been lucky. But I've had 3 of these now and really never had any problems except the first one. And then if you want just amazing quality out of the box, you can either get it in a DIY or kit and make it yourself, or you can just buy it where it's pre-built and pre-tuned. I fell in love with the Prusa. I do have the Lulzbots, and I really like those a lot as well. But both Lulzbot and Prusa will do all the exotic filaments. You can do nylon, carbon fiber, and so forth. And the one thing I do like about the Lulzbot is it has swappable hot ends, so that whole print head will pop off. You unplug one harness and you take one bolt out, the print head comes out. I can swap more on. I can change it. If I wanted to have dual colors, I can put a dual color print head on. If I wanted a print larger volume products, I can swap out that hot end. So that's the reason why I like the Lulzbot. The Prusa, the quality is just amazing out of the box. If you want something that almost looks like you bought it at the store, if you crank down the resolution on the Prusa to really super high resolution, it will look almost like store-bought or an SLA printer, which we haven't talked about SLA printers, so we're talking more about this, but it prints extremely well. I can't say enough about it. I have the Prusa Minis. I haven't tried them out yet, but I have a few friends that have bought the Prusa Minis, and the Prusa Minis are are quite inexpensive. They're more of a kit only. So yeah, not as much of a kit as a kit MK3S, but you do have to spend maybe an hour or so building the Prusa Mini. And the Prusa Mini seems to give almost similar print quality. I've the friends that have sent me models, it's very similar. So I'm very happy with the product. I would say these three are pretty solid choices, depending on what your budget is. Obviously, this one's quite more expensive, but they all have great aftermarket support. They all have great upgrades that you can do yourself. Some of the manufacturers even produce upgrades for them, very similar like Prusa. What's up top on that top of that printer? That's their Prusa multimedia print head that allows you to feed up to 6 different colors into your printer. And once you get it all set up, you can print out full solid color products as well when you do it. So a lot of different options, a lot of different types of avenues you can go down for your printer selection. The last one, I didn't have a slide built for it, but there are printers that are SLA printers. Basically, they take a light and some liquid material, and when it prints in slices and prints it against dips this build plate into this liquid material. It shines the light on it and heats up the material, and then by doing that multiple times over time, it ends up building a very similar 3D product as if you could do on a 3D printer. The build quality on those are quite good. You can't see what's commonly known as layer lines in the print. Layer lines is when you look at the edge of it, you can see that it was built layer by layer. So there's a small line for every layer that it makes. An SLA printer really can eliminate a lot of that. There's some additional overhead. I don't always recommend it as an out-of-the-box new person to 3D printing because SLA printers have some very, very bad fumes they give off. Whether they're harmful to you or not, they can be a little risky. So I wouldn't recommend that as your first printer. I from friends that use them, they have a love-hate relationship because the print quality is amazing, but it can give off some pretty toxic fumes while it's printing. At the same time, you can't just print something and be done. You have to print something and then you have to kind of do a quick wash, and then you got to cure it as well, because when it comes right out of the printer, it's still a little soft. And so you have to cure it in either a curing station or by sitting it outside in the sun. So it cures that product to where it's hard and clear. It requires a lot more effort put towards it. So if you've already had 3D printers and you're looking to go into SLA, I would say that's go for it. Just know that it's probably best to put it in a room that you're not going to be in a lot, or put it out in your garage. But otherwise, it's an option. For those that are looking at just getting into a start with the 3D printers, the 3 that we discussed, like we did earlier, we discussed the Ender 3, the Monoprice Mini, as well as the Prusa. Those are some great printers that give you a lot of options. For Mike, for your printer under 4K, to be honest, Lulzbot has some great products that'll do all that nylon, carbon fiber, and various other filaments. I would personally recommend, Prusa, Lulzbot. If you're going the Lulzbot path, I would say look at Sindaver. Sindaver is the company, they evolved Lulzbot's product, and I want to say made it better. It's about $3,200, $3,000 for the printer. It has some amazing features and fixes some of the problems that Lulzbots inherently have. I'll flip back over to my Lulzbot picture. So if we look at the Lulzbot picture, Lulzbot has a problem with their auto leveling. They have these little silver discs at the corners of the bed. Over time, if you're not constantly keeping your nozzle clean, or these don't have perfect electrical conductivity or grounded out properly, these auto leveling discs won't work quite right. And over time, your auto leveling won't work, and your printer will constantly error out. It can be a pain. So that's why you end up with a love-hate relationship sometimes with Lulzbot printers, specifically for that given reason, because these discs, when they measure back the resistance and position, they have to be within millimeters of one another, like very, very like a micromillimeter of one another on all four corners. Otherwise, if they're above a specific threshold, your printer will error out. Or if the resistance isn't great enough, the printer will error out. Or if something happened, and which can happen over time, if it didn't get good connectivity on one of these, the printer will sometimes push harder on that disk to try to get better connectivity. And if it doesn't achieve it, it'll end up pushing your bed down a lot in that corner. If it does it over time, it can make your bed a little lopsided. Sometimes just slightly lopsided, where you won't even really notice it, but it's enough that your printer will notice it and can't level the bed. Which is why I like them, because they work when they work. But if that starts to happen, it becomes you've got to troubleshoot it quite frequently. I had one, this printer in the picture specifically developed that problem. So I had to tear the bed apart, check all my wires, and then ultimately found that one of these discs were a little off. So I had to clean that all up, cut some material out, grinded a couple spots out, and then put it back together, and it fixed it. But that's what happens with the Prusa. The probe on this printer is crazy fast in terms of auto leveling. The auto leveling sequence on a Lulzbot can take, this sounds being nitpicky, but 30 seconds to a minute or more to auto level. The Prusa can level in about 10 seconds. It rips through auto leveling the bed. It checks 9 points on the bed, and it's done. So a lot of options to think through. But hopefully this gives you a good start to where you want to go with your 3D printing. If you have questions, feel free to toss them in the Q&A or in the chat. I can hang out for a couple minutes to answer questions. If you don't have questions, I can tell you good night. And hopefully you have some great experiences with your 3D printers. They're fun. Don't get down if you run into an error, or don't get discouraged. It happens. It's inevitable. But ultimately, a great experience to have. Thanks, Mike.
I'm just going to pop in to add here that this is being recorded, and we will have it up on our YouTube channel later, probably next week. So if you need to watch it again, it will be available there. And then don't forget the webinar at the end of November, the last Monday in November, and actually the last Monday in December, when Justin will be back talking about how to maintain one, and then what are some of the things that you can print with a 3D printer.
Yeah, those will be fun. Hopefully by then you've picked up one of these printers and you've had a few minutes to tinker around with it. And feel free to come to the session with troubleshooting questions, especially on the how to maintain one. That's some we'll get in depth with how to fix and repair some of the issues. All right. Well, thanks everybody. If you have any more questions, feel free to toss them in there. Otherwise, I will see everybody in a month. Have a great evening.
Everybody have a good evening.